Hello smart mathematicians, let's do question 7.1. Determine the derivative of f of x from the first principles. And then we're given f of x there. This is 5 marks. Don't be tempted to use the rules here. We have to use the first principles. And then we find the formula in the formula sheet. It says f of prime x. F prime x is equal to lim h approaching 0, then f of x plus h minus f of x over h. Let's start by finding f of x plus h. So where there's x, we put x plus h. So it's going to be f of x plus h is equal to x plus h squared plus x plus h. Then that's what we have there. So we can say f prime x is equal to lim h approaching 0. And then we have this. So it's going to be x plus h squared plus x plus h minus, be careful there, your f of x must be in the bracket. So minus x squared plus x. All this divided by h. Right. So let's simplify this f of x plus h. This is a square binomial. So you can say x squared, square the x, becomes x squared. Then 2 times x times h is plus 2xh, and then you square the h plus h squared. And then plus x plus h. Right. If you want, you can use the FOIL method here. Remember, x plus h squared is equal to x plus h times x plus h. So x times x, that is x squared, and then x times h there, that is xh, then h times x, this is xh, then h times h, that is h squared, which simplifies to x squared plus 2xh plus h squared. Okay, right, which is this part here. Now we are going to replace this whole thing here by this. Becomes f prime x is equal to lim h approaching 0, and then we have x squared plus 2xh plus h squared plus x plus h. We're distributing -1 here, so it becomes negative x squared minus x. All this divided by h. And then x squared minus x squared is 0. X minus x is 0. So we remain with f prime x is equal to lim h approaching 0. Then we have 2xh plus h squared plus h divided by h. If you check the numerator there, we can factor out h. So it becomes f of f prime x is equal to lim h approaching 0, then h, then 2x, h squared divided by h is h, then h divided by h is 1. So remain with that over h. And then h divided by h is 1. So we're remaining with f prime x is equal to lim h approaching 0, and then 2x plus h plus 1. Then where there's h, we put 0. Where there's h, we put 0. So f prime x is equal to 2x plus 0 plus 1. Once we substitute the 0, where there's h, the lim sign disappears. So we remain with f prime x is equal to 2x plus 1. So we have derived f of x using the first principles.